Hello everyone, my research investigates pyroclastic density current ice interactions and the conditions in which ice melt lahars are formed. When PDCs interact with ice, they generate steam and melt which can be incorporated into the flow, resulting in alterations to the flow dynamics. PDCs and ice melt lahars represent some of the most hazardous volcanic flows, yet quantifications of the physical processes required for accurate hazard modelling of these surface flows are limited. The experiments presented here address this. In experiments, particles of varying type, layer thickness and temperature are released onto a horizontal basal layer of ice contained within an insulated beaker. Particles are left on the ice for a duration of 10 minutes and the time evolution of temperature through the particle layer is recorded using interspersed thermocouples. After 10 minutes, a mass balance of ice, melt and steam is measured. This data is used to quantify heat transfer from particle to ice and to quantify melt and steam generation and their incorporation into the particle layer. So what we can see from these graphs is that melt and steam systematically increased with particle temperature and layer thickness. Above 400 degrees C, steam was observed to alter the dynamics of the particle layer through fluidization, localized steam escape and enhancing the mixing of melt into the particle layer. The implications of the incorporated melt and steam in natural PDC ice interaction settings is reduced frictional contacts with the ice layer and within the particle layer and increased mobility. Further experiments will be conducted to study flow mobility in lahar forming processes on an incline and at larger scales. This data will then be incorporated into surface flow hazard models for PDC runout and lahar generation, enabling accurate prediction of PDC ice interaction hazards. Thank you for listening.